I'm Josephine, Assistant Professor of Physics, Navaya Engineering College. Now I'm going to explain about VI characteristics of PN junction diode. So this VI characteristics of PN junction diode, we're going to discuss in three different circuits, that is zero bias, forward bias and reverse bias. So first we'll see about zero bias or unbiased circuit. So when the junction is not connected to any voltage source, it is said to be unbiased. That means if the PN junction diode is not connected to any battery, then we say the diode is under zero bias. Then there is no flow of charge carriers, hence there is no current flow through the junction due to the potential barrier across the junction. Next, forward bias circuit. When the positive terminal of the battery is connected to P-type and the negative terminal of the battery is connected to N-type, then the junction is said to be forward bias. If P-type is connected to positive terminal and N-type is connected to negative terminal, then the diode is said to be forward bias. Since the potential barrier height is very small in forward bias, when the applied voltage exceeds this value of 0.2 volts, then the junction resistance becomes almost zero, hence low resistance path is created. So even for small increase in applied voltage, we observe large increase in circuit current. Such a circuit is called forward bias circuit and the current is called forward current. When the applied voltage is above the barrier potential, then we found a high current will be developed in forward bias. Now we'll see about reverse bias circuit. When the reverse bias means if the positive terminal is connected to N type and the negative terminal is connected to P type, then the diode is said to be reverse bias. So in reverse bias, a slight reverse current flows in this circuit. Even for large increase in bias voltage, that is around 20 volts, there is negligible in reverse current. That means in forward bias, we are able to develop a high current. In reverse bias, negligible currents will be developed. When the applied reverse voltage is high enough to break the covalent bonds of the crystal, the current rises suddenly in the reverse direction. The breakdown voltage in reverse bias is called Zener voltage. So in reverse bias, where there is a sudden increase in the current, that particular voltage is known as breakdown voltage or Zener voltage. So this is the VI characteristics of PN junction diode. So this is the forward bias, how it works, and this will be the reverse bias. So in forward bias, when you change the voltage, that means if you increase the voltage, there is a growth in the current, slight increase in the current. In forward bias, whenever you apply a voltage which is above the barrier voltage, then there is a high amount of current developed in forward bias. Now in reverse bias, a voltage where there is a sudden growth in the current is called Zener voltage or breakdown voltage. So this is the region where there is a sudden growth in the current for this particular voltage. So we'll call this voltage as Zener voltage or breakdown voltage. So we are discussing this VI characteristics of PN junction diode in three ways. One is zero bias, second one is forward bias, and the third one is reverse bias. So in forward bias, we are able to develop a high amount of current, and in reverse bias, minute currents will be developed at a voltage where there is a sudden growth is called Zener voltage. So this is about VI characteristics of PN junction diode. Thank you.